Good evening friends, I hope you are following thermodynamic video lectures thoroughly. So today our goal is to learn about the specific heat capacity at a constant pressure. In the previous video what we discussed means we discuss about the specific heat capacity at constant volume. As we know, the amount of heat required to change the temperature of the body, it depends upon two parameters. One, how much temperature we increases. Second one, the number of moles of the substance. Then the amount of heat required to raise the temperature of the body, Q, is directly proportional to the number of moles of the substance. Now N is equal to number of moles of the substance. Now again this is the first condition. Now again the heat required to raise the temperature of the body depends upon the change in temperature of the substance. So the another one is the delta T is equal to change in temperature of the substance. To understand these two conditions, you can easily say that, let's assume here is the two substances are there. So the first one is having the 1 mole of substance. So let me take this is the 1 mole of substance. The second one substance is the nearly 10 mole of substance. Let's assume I am taking this is the substance. The substance means it is generally we will discuss the ideal gas. So this substance is having a 10 mole of substance. Now we are going to increase the same temperature between the two substances. So we are going to increase the same temperature increment in the two substances. Let me take the delta T is equal to, now let me take this is the, this substance is at room temperature 30 degrees Celsius, this substance also having at room temperature 30 degrees Celsius. Now we are going to increase 1 degree Celsius of this substance, we are going to increase 31 degrees centigrade. This substance also going to increase the 31 degrees centigrade, from 30 to 31 degrees centigrade. Now we increase the substance temperature only 1 degree Celsius, but the first substance is having at 1 mole, but second substance is containing of 10 moles. That means if the delta T is constant but the number of moles are not constant, then if more number of moles or substance is available, then we need to supply large amount of heat energy. That is only the first condition is saying the heat energy supplied to the system is directly proportional to the number of moles contained in the substance. Q is directly proportional to number of moles contained in the substance. Now if we go to the another condition, now I am taking only single substance that is having only 1 mole substance. This is the 1 mole, this is the 1 mole. Now here is the 30 to 31 degrees centigrade we are going to increase. Now the second condition I am going to increase 30 to I am going to increase the 80 degrees centigrade. Now the change in temperature of the same substance which is having the same number of moles, it is required more amount of heat energy because we are going to increase larger amount of temperature difference. That means here is the number of moles are constant but the change in temperature of the substance is differ. So that is equal to the amount of heat energy is directly proportional to the temperature difference of the substance. By combining these two equations, what we can go means, now if we combining the both two equation means Q is directly proportional to N into delta T, so R dt. So with help of this equation the proportionality constant I am removing. Now we are performing this one at constant pressure, the pressure is constant. So now if you are doing this one at constant pressure, so Cp into N into delta T. So this is the proportionality constant, this will call is the specific heat capacity of the substance at constant pressure or molar specific heat capacity of the substance at constant pressure. Now our goal is to define this Cp value, then keep the Cp value one side, then Q divided by N into dt. Now the Cp can be directly equal to the Q, that is the supplied heat energy to the system, if the N is equal to 1 mole of the substance, if dt is equal to change in temperature of the substance is equal to 1 degree rise in temperature, 1 degree rise in temperature. But where we are doing this total process, we are performing this process at constant pressure of the substance. Now we can give the definition for the Cp. The amount of heat, that is nothing but a Cp is equal to Q when if n is equal to 1 and delta is equal to 1, that is equal to, this is the amount of heat required to rise the temperature of the unit mole of substance by 1 degree constant 1 degree at a constant pressure is called the Cp. So let me take one more time. So I can take, this is the at a starting point, at constant pressure, the amount of heat required to rise the temperature of the unit mole of substance for 1 degree is called the Cp. So that is the Cp value. Now I hope you understand what is the units for the Cp. Let me go to the units for Cp. Cp units for Cp. Now let me take the formula for the Cp. Cp is equal to 1 by n into d or q divided by dt. Now what are the units for n? N is equal to moles are the unit. What are the units for q? Q is the joules for units. What are the dt units? It is the temperature difference Kelvin. Then Cp units are Cp units. I am taking SI system units, joule, mole inverse, Kelvin inverse. This is the units. Now what are the CGS units? This is the SI units. What are the CGS units? So it is the calories and mole inverse and degree centigrade inverse. This is the CGS units. Now what are the dimensional formula for the Cp and Cv? Both are same only. So dimensional formula. So dimensional formula means we need to take the basic formula for the Cp. Cp is equal to Q by n into dt. So Q dimensional formula is equal to, it is the work and energy, both are same only. So work is equal to m L square T power minus 2 divided by n. Number of moles is equal to, dimensional formula for mole is equal to mole, and dt temperature is equal to Kelvin is the dimensional formula for temperature. Then dimensional formula for the Cp is equal to m L square T power minus 2 mole inverse Kelvin inverse. This is the dimensional formula for the Cp, and the Cv also same dimensional formula, same units will come because of we are performing the same process at constant volume. That means Cp and Cv both are having the same units and same dimensional formula, same units and same dimensional formula. That is the important. So I hope you understand about this lecture. Thank you.